Thank you for spending your time to watch this movie. My name is Takeuchi, and today I'd like to talk about my joint work with Erika Seki titled Coordination and Free Riding Problems in the Provision of Multiple Public Goods. Our motivation comes from many newspaper articles which suggest that there are efficiency losses from too much donation in one place or time, causing too less donations in other places and time. For example, Japan is a country with many natural disasters, and thanks to the society, many people goes to these locations to volunteer. However, we often see news which suggests that there are too many volunteers in some locations, whereas there's not enough in other areas. Thus, there's misallocations of post-disaster volunteers. Similar things happen with timing of blood donations. Blood products are perishable goods, and some blood products have very short storage life. So excess supply of blood product in one period causes a shortage of blood product in the other periods. These examples can be considered as a problem of provision of multiple nonlinear public goods. There are many locations and timing of donations, so it is multiple. It is nonlinear because highest efficiency is not obtained when people fully contribute. Oftentimes, in these situations, there are certain needs for donations and volunteers. Any excess amount beyond the need is wasted. Thus, as a society, it is important to coordinate on which public good to contribute in order to improve efficiency. Given these motivations, our research question is as follows. Is it possible to improve efficiency in the game of multiple nonlinear public goods by providing information of the needs? The reason for studying the effect of information provision is as follows. First, this information of the need is often lacking in real life. Second, if it is found to be useful, then it is low in cost to implement. Finally, it is decentralized institution which does not interfere with people's will to volunteer or donate. In order to study this effect, we model the situation as nonlinear multiple public goods game and use game theory to make theoretical predictions. Then, we use laboratory experiment to test the theoretical prediction. In today's talk, I will mainly focus on the laboratory experiment part of the study. First, I'd like to introduce our model. This game has multiple public goods. For comparison with existing experimental literature, we made our game nonlinear while trying to keep it as close to the linear public goods game as possible. We did this by introducing an upper bound on effective contributions, which we called the needs in this presentation. In our model, there are two public goods, and the payoffs to the individuals are the gain from the private good, endowment minus the cost of contribution, plus the gain from the two public goods. The gain from the public goods can be written by this equation. Let us illustrate this situation by using a diagram. This diagram shows the relationship between the sum of contributions and the gain from the public goods. Let's say this dotted line shows the level of full contributions. Then, in the usual linear public goods game, the gain from the public goods constantly increase up to the full contribution level. In this game,
、okay, we introduce the needs.
we introduce the needs. 、okay, 。 We introduce the needs. 。 Okay, 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 people's contribution increases the gain from the public goods up to the needs. However, any contribution beyond does not increase the gain anymore. Next, in order to analyze the effect of information, we compare two information conditions regarding the needs. In the partial information condition, which reflects the situation without the information provision, the need for each public good is randomly determined, and the players only know the probability distribution, not the realized value. On the contrary, in full information condition, which reflects the situation with information provision, players knows the realized value of the needs. In the theoretical analysis, we found that information provision does not matter if people are self-interested. But if people are efficiency concerned, then full information obtains higher efficiency than partial information in equilibrium. Theoretically, depending on the type of individuals, the effect of information provision differed. Thus, we conducted laboratory experiment to analyze the effect of information of contribution rates and efficiency. Here is our experiment design. Our main treatment are the comparison of information conditions. And we did this experiment in between subject design, which means individuals only participate in one of the two treatments. The subject played the game 10 times in groups of 4 with the same member every round. We randomly changed the information of the needs with every round. Other details of the experiment are as follows. Our main findings of the experiment is as follows. First, at the aggregate level, we found no effect of information provision. The left figure shows the average contribution rates in each period, and the right figure shows the efficiency. As the figures suggest, we were not able to reject null hypothesis from the result of the test of two sample means. Thus, at the aggregate level, information provision does not improve contribution rates and efficiency. However, a more detailed analysis reveals a countervailing effect of information about the needs on donation rates. This is the result of random effect panel data analysis using individuals' contribution to either public goods in each period as a dependent variable. I'd like to draw your attention to the top two rows. As the first row suggests, the overall effect of information provision is negative. The coefficient on information dummy, which takes 1 in full information treatment, is negative. However, donation rates does seem to improve with the need. Whether we should provide the information or not depends on the needs. When there is a large amount of needs for volunteer or donations, providing information will likely increase donation and efficiency. To summarize, information on needs may or may not improve the efficient provision of donation. Donation rates increases with the amount of needs, but information itself reduces the contribution rates. Thus, information improves the coordination failure, but causes more free riding. The question is why the information reduces the contribution level. We speculate that strategic uncertainty and fear of wastage makes individuals to withhold contribution in full information treatment. However, we need more experiment to test this hypothesis, And this is our future work. Thank you very much for listening.